Today we're going to learn how to multiply algebraic expressions with exponents. And we need to start by reviewing some rules for multiplying with exponents. Here's the first one. If I have x to a power, I'll call it m, times x to a power, I'll call that one n, I just add the exponents. That's x to the m plus n. Now notice these bases must be the same for us to use that. So a real simple example would be if I had x to the third times x to the fifth, that would be x to the eighth. 3 plus 5. Easy enough? Okay, so that is the rule for multiplying. All right? Now, I'm going to call that one situation 1. What if I had this situation? X to the third times y to the fifth. Well, you cannot do anything. I cannot add the 3 and the 5 because the bases are not the same. So this one stays the way it is. There's nothing I can do to it. This is just x to the third, y to the fifth. Okay? All right, the second rule is the power of a power rule. This is if I have x to a power, the whole thing raised to a power, like that. In this case, I multiply the powers. This is x to the m times n. You multiply the two powers. So, easy example, if I had x to the third all to the 7th power, that would be x to the 21st, 3 times 7. Okay? This is called, you might want to put this down, this is the power of a power rule. Now, we have another situation. I'm going to call this the next example. And in this case, as a matter of fact, let's not call this an example. Let's just call this a rule. Okay? This will be rule number 3. Rule number 3 is this. If I have x to a power, y to a power, all to a power on the outside, like that. X to the a, y to the b, the whole mess to the m power on the outside. Well, what I do is I use what I learned on the power of a power rule, but I have to distribute it to both of these. So this is x to the a times m, y to the b times m. This one's not a hard one. It's you basically think distribute. So for example, if I had x to the third, y to the second, all to the 4th power on the outside, then I just distribute the multiplication to both of those. This is x to the 12th, 3 times 4, y to the 8th. Okay? You just distribute the power on the outside to both on the inside. Now, let me show you something. note, if I have this, you need to notice that this is not the same because of the plus sign. This plus sign means that you cannot do the same thing that I did up here. All right? So you do not distribute this 4. This 4 I cannot distribute to the 3 and the 2. All right? That is not a rule because of this plus sign. Okay? So, let's get to some more examples like you're going to see in your assignment tonight. You're going to be asked to simplify. And our first problem is 6n to the third times 2n to the 7th. Now, don't let the parentheses freak you out. They're just trying to keep the two terms separate. All right? So, watch how we tackle this. First, let's multiply the coefficients. 6 times 2. That's 12. I'm going to have an n. I need to decide what power I've got. Well, I have n to the third times n to the 7th. So that's the very first rule we learned today. This is where I add them. That's right. This would be 12n to the 10th. And that's the answer. Okay? Let's do another one. 3p t to the third times p to the third t to the fourth. Now the reason I wanted to go over this one is because sometimes people don't know what to do with this p right here. If there's no power written with the variable, then the power is 1. All right, if there's no power written, then the power is 1. Now we just do it like the last one. 3 times 1 is 3. I have p to the first times p to the third, which becomes p to the fourth. That's right. And I have t to the third times t to the fourth, which is t to the 7th. That's the answer to that one. Here's another one that throws people off sometimes. Looks very easy, but I often get questions about this. This is just a to the first times a to the fifth. That's what's going on here. So this is just a to the 6th. That problem's done. All right, don't let the way that it's written confuse you. Okay. How about this one? They've got this crazy pi on the outside, and then they've got this exponent thing. Well, the pi just acts like a number, and the pi does not have a power with it. So basically, the pi just gets multiplied by whatever I get from this thing right here.
So when you
I would distribute. Okay? So I would have 2 to the second, x to the second, y to the fourth. Remember, when we have a power to a power, we multiply the powers. And now I can finish this up. This is going to be a 4 So we can write this a little bit better. We can write this as 4 pi, and then the rest of it stays the same. X squared y to the 4th. All right. Now, you may have to deal, well, you will have to deal with negative numbers. And raising a negative number to a power. So, and the calculator can help us here. But let's say that you have negative 2 x y to the 3rd all to the 5th. Now, we need to distribute the 5 to all of these, but we need to do it carefully. This is not negative 2 times 5, it's negative 2 to the 5th power. Be careful with that. A lot of people get in a hurry and they say that, oh, that's negative 2 times 5, that's negative 10. No, it's negative 2 to the 5th. X to the 5th, y to the 15th. Remember, power to a power, we multiply. And at this point, this is a good place to turn to the calculator. All right? So if you want to turn on your graphing calculator, the way that we're going to find this thing right here, here's your keystrokes. You're going to do negative 2, and then you're going to press the caret button, which is like an upside down B, and then you'll press 5, and then hit enter.
Negative 32.
And yes, it should be negative 32. So this is, my final answer is negative 32, the rest of it stays the same. X to the 5th, y to the 15th. And I want to do one more problem. I will help you out with the calculator in just a minute if you have any calculator issues. Let's do one more problem. This one is one of the uglier looking problems, and I want to do one of these so that you see it. 3x y to the 4th all to the 2nd times this thing in brackets, negative 2 y squared bracket cubed. Now this thing looks really scary, but what we should really do is think of it as two little problems. One thing times another. So let's think of it, let's put a times symbol right there. And let's think of this problem times this problem. And that's going to help us a little bit. So on the first one, I need to distribute this power on the outside to everything on the inside. So that makes it 3 to the 2nd, x to the 2nd, y to the 8th. Let's go ahead and finish that one up. 3 to the 2nd is 9. 9, x to the 2nd, y to the 8th. Remember that 3 to the 2nd means 3 times 3. It's not 3 times 2. Now, on this thing over here, this bracket, you can really just think of as another parenthesis. Okay? Don't let that worry you too much. So the first thing I have is a power to a power right here. So that's 2 times 3. So this will now be negative 2y to the 6th. Just take one piece at a time. Work slowly on these problems. Well, I have power to a power. Again, I need to distribute this power to both of these terms. So now I have negative 2 to the 6th, y to the 6th. That would be a good place to use the calculator. Negative 2 to the 6th should be positive 64. All right. So this turns into 64 y to the 6th times 9x squared y to the 8th, and we're almost done finally. Somebody on your calculator, find out what 9 times 64 is.
576.
576. X to the second does not change, but I need to add those two. So that becomes y to the 14th. And we will stop there for today.